Hello everyone, in this video let us continue with the library Numpy and let's see the methods and functionalities of it. So initially let's initialize a Numpy array and let us add some integer 1 to this Numpy array and let's see what will be our output. So here if we observe, for each and every element we are adding 1 over here. So 81 is becoming 82, 10 is becoming 11 and 20 is becoming 21 like that. So you might be thinking this might work on list as well, but it will not work. Let's see what it is giving on list. So here if you observe, it is giving us type error. Okay. So this operation will not work on list, whereas it will be working on NumPy arrays. Okay. And similarly, we can add 10 as well. And apart from addition, we can do multiplication, float division, integer division, subtraction, power, all those operations as well. Even mod also we can apply. So let's see one by one. So what it is doing, it is multiplying with 2 for all the elements in ARR. So in ARR, first element is 81. 81 times 2 is 162. And second element is 10. 10 times 2 is 20. Like that, for each and every element, we are multiplying 2. And this is float division. Okay, and this is integer division, and this will also work in a similar fashion. And now we are going through subtraction, and similarly we have this operation. What is this operation? Anyone remember? It is power. So it will do power 2 for each and every element. And similarly this will be returning us mod value on like doing mod with 2. What will be the value that will be returned for each and every element? So here if I observe 100, that means that this is the odd number, that is 81, and second one is 10, and it is even. So this signifies that like 1 means that it is odd and 0 means that it is even. Okay. And even we can do like this. So what this will be returning us? This will be returning us NumPy array of true and false. Okay. So whenever it is 0, it will be returning us true, and whenever it is 1, it will be returning us false. So let's check it. So it is returning a NumPy array, and wherever there is 1, it is returning us false, and wherever there is 0, it is giving us true. Okay, like that, this particular thing will work. And let's take a NumPy array, and on this, we are passing this specific thing over here. So what I'm doing, ARR mod 2, if double equal to 1, then like let's see what this will be giving us. So it is giving us all the odd numbers. That means that whenever like this is true, this particular value is true, only those elements will be extracted. That's why we are having 1, 3, 5, 7, 9, and 11. Okay. And similarly, we can do like assigning as well like this. So all these odd numbers will be changed to an integer that is 10. So let's assign it 10. Let's see. So here if you observe, wherever there is 1, 3, 5, 7, 9, and 11, those all got changed to 10. Okay. Now let's take two arrays and let's add those two. So what will happen? Element wise additions will happen. Okay. So in this case, let's add some other element over here. So I'm adding 11 to ARR1. Then what it will do? It will be giving us error. Okay. Whenever we are doing two NumPy arrays addition, we should make sure that both are having same dimension. Okay. So as they are not maintaining same dimension, we are getting this error. But let's continue with same dimension and let's do addition. And it is giving us element-wise additions. And similarly, we can do multiplication, all other operations as well. Okay. So let's take a 2D array, 2D NumPy array. So in this, we are having 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's multiply ARR1 and ARR2. So if you are directly multiplying like this, then it will be element-wise multiplication. So if you observe 1, 4, 9, that means that everything is squared because each like exactly these two are same. Okay, that's why these are getting squared. And if you wanted to do matrix multiplication, so if you observe these two are matrices, okay, 2D matrices simply. But we might wanted to do matrix multiplication, and that matrix multiplication output will not be this one. So let's see what will be the output of matrix multiplication. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and we are multiplying with same 1, 2, 3, 4, 5, 6, 7, 8, and 9. So in matrix multiplication, how we'll be doing? We'll be taking the first row, the first column, and we'll be multiplying element wise and we'll be adding. So it will be 1 into 1 plus 2 into 4 plus 3 into 7. That is 1 plus 8, that is 9 plus 21. So first value will be 30. Okay. So in the answer, first value will be 30. And let's see the second value. For the second value, we'll be multiplying this row with this column. So it will be 1 into 2, 2 plus 2 into 5, that is 10, and 3 into 8, that is 24. So 24 plus 12, how much it will be? It will be 36. Like that, we'll be calculating all the elements. So let's check whether it is matching these two or not. If that is matching, then that means that it is matrix multiplication. Okay. So here, if we observe, let's apply this dot operation. So it is giving us 30, 36, and the next values will be these. Okay. So to just prove that this dot operation is giving us matrix multiplication, I have shown you this. Okay. So let's continue. So let's take 2D array with different dimension and let's try to multiply those two. So if we try to do this, it will raise us value error because we have discussed in case of addition also. Whenever we are doing these operation directly, we should make sure that the dimension should match. But here, if you see, ARR1 is 3 cross 3, and now we are changing ARR2, and it is becoming 3 cross 2. Okay, we can't do this because the dimensions are mismatching. But if you see, like if you remember, we can do matrix multiplication. Let's say if there is m cross n and there is n cross m or n cross something, n cross y. On applying matrix multiplication to these two matrices, we will be obtaining m cross y matrix as output. Okay, so we should make sure that this and this dimension should match. So in matrix multiplication, only criteria is the number of columns in the first row and number of rows in the second row should match. Okay. So here in this, if you observe, there are 3 rows and 2 columns, whereas in this there are 3 rows and 3 columns. So in this, the number of columns and in this, the number of rows are matching. So we can do matrix multiplication over here. So this will be giving us some output. Let's say we change it to 2 cross 2. Then we can't do both because this for this we need to match dimensions exactly. And in this, we need to match the number of columns in ARR1 with number of rows in ARR2. But both are not matching. That's why these two will give us error. Okay. Now let us take ARR1 and ARR2, some different arrays. And we can compare to ARR1 and ARR2 like this. So what this will be returning us? This will be returning us NumPy array of true and false. So like if it is true, when it will be comparing element wise, and whenever it is true, it will be returning us that particular either it is true or false like that. Okay. So let's see. So here these two are equal. So that's why it is returning us true, and these two are not equal. That's why it is returning us false. Like that, it will do element wise operations, and it will be returning us whether it is true or false. And similarly, it will work for greater than or equal to, and similarly less than or equal to. All those will work. And like np.array equal, what this will be doing, if all the elements are exactly equal, then it will be returning us true, else it will be returning us false. So if we see ARR1 and ARR2, here it is 3 and here it is 2. So both are not exactly same. So that's why it will be returning us false. Okay. And let's take same values as ARR1. So these are the same values that are present in ARR1. So this will be returning us true. Okay. Now let's take some like 0011 in A and 0101 in B. Now, if you remember, what is logical AND? Logical AND is when, so logical AND is like if we are taking input A and B, and on this, if we are applying logical AND A and B. So whenever this is true and whenever this is true, then it will be returning us true. And if any one of these is false, then it will be returning us false only. So if this is false, it will be returning us false, and this is false, it will be returning us false. If both are false, obviously it will be returning us false. So and work in the way that if like one of the things is false, then the output will be false. And how will OR work? If one of the things is true, then the output will be true. If both are false, then only it will be false. So the output for this will be true, 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 and false. Okay. And what is not of A? So when there is true, on applying not, it will become false, and here it is true, so it will be false. And when here it is false, it will be true, and here it is false, it will be true. And similarly, we can get not of B as well. And there is some other operation that is XOR. So A XOR B, what it will be? In XOR, if both are different, then it will be returning as true. If both are same, then it will be returning as false. So if you observe here, A and B are same, so it is returning as false. And F and F both are false, so it will be returning as false. But in case of this, true and false both are different values, so it will be returning as true. And similarly, here it is false and here it is true. Here also it will be returning as true. Okay, like this and or not and XOR will work. Let's see how we will be doing that in this. So here if you observe, we have np.logical and to this we are passing these two numpy arrays, and it will be doing element-wise operations of logical and it will be returning us the output. So if you observe, what is and? If any one of those is false, then it will be returning us false. So for these first three things, like there is zero in one of those, so it will be returning us false, 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 true. And when it comes to OR, it will be giving us false in the first case, and remaining cases it will be returning us true. And similarly, there is XOR we have discussed. Whenever these two are not matching, then it will return us true, and when they are matching, it will be returning us false. Okay. And we have not as well. So what not will be doing? It will be whenever it is zero, it will be returning us true, and whenever there is one, it will be returning us false. Okay. Like it will just invert the values. And like in digital logic, we have NOR, NAND, and some other functions as well. So in order to like implement those, we don't have separate functions over here. So if you see logical NOR is not there, that's why it will be raising as error. But if you wanted to find NOR, then you can simply do it like this. To logical NOT, we can pass this logical OR. Like that, we can obtain NOR. And similarly, NAND also we can obtain. To this NOT, we'll be passing logical AND. Okay. And also we can apply NOR by passing to this logical AND by passing logical OR, XOR. Okay. Like that, we can obtain this NOR, NAND, and NOR. Okay. Let's take some other array, NumPy array, and we can find min, max, mean, standard deviation of these NumPy arrays. So like that, even this can be possible with NumPy. So in this min is 34, minus 34. That's why it is written as minus 34. And let's see the max value. It is 78. And mean of the whole array, it is 18.72 something. Okay. And standard deviation is 30.48. And let's see whether there is median term or not. So median is not there. So in NumPy, we have a separate function or separate method for median, that is np.median. So to this, we'll be passing the array. So then it will be giving us that particular median value. And there is argmin as well. Argmin, what argmin will be doing? It will be returning us index of the minimum element. So if you see, it is telling 10th index. So in the 10th index, we'll be having this minus 34. Okay. And similarly, argmax will be telling us the index of the maximum value. So it is telling 3. So in the third index, let's see what is there. So in the third index, we have 78, and it is the largest in this whole array. Okay. Like that, argmin and argmax will work. Now let's take a two-dimensional array. So in two-dimensional array, we have 2, 7, 9, 8, 3 minus 1, 3, 0, and 1. Okay. On that, let's take ARR1 of min. So if we are passing like this, it is considering the whole two-dimensional array. In this whole array, whichever is the minimum, it is returning that. But if you wanted to do like row-wise or column-wise, then let's see how to do. So if you are passing axis equal to 0, what does that mean? That means that we wanted to see vertically. So here, if we observe, it is 27983 minus 1 and 301. So let's write it over here. 27983 minus 1, 83 minus 1, and 301. These are our matrix values. So axis equal to 0 means we'll be seeing in vertical axis. So when axis equal to 0, we'll be considering the vertical axis. That means that this axis. In this axis, what is the minimum? 2 will be our minimum. And in this axis, what will be our minimum? 0 will be our minimum. And in this axis, what will be our minimum? -1 will be our minimum. So when x is equal to 0, our output should be 2, 0, -1. Okay. And when our x is equal to 1, it will be considering horizontal axis. That means that in this, what will be our minimum? It will be 2. This is 2, 7, and 9. Okay. So in 2, 7, and 9, 2 is minimum. And similarly in 8, 3, -1, -1 is minimum. And in 3, 0, 1, 0 is minimum. So when x is equal to 1, our output should be 2, -1, 0. And when x is equal to 0, our output should be 2, 0, -1. So let's see it is giving like that or not. So here x is equal to 0 and our output is 2, 0, -1. So here if you see it is giving 2, 0, -1. Yeah, it is exactly matching. And similarly when x is equal to 1, it is 2, -1, and 0. Here, see 2, -1, and 0. Like that this axis will work. And there is some other function that is called as revel. So what this revel will be doing, it will be like if we are having some two-dimensional elements like this, so it will be converting all those into some single dimensional thing. So if you see 2, 7, 9, 8, 3, -1, 3, 0, 1, all those will be getting into some single dimensional numpy array. So let's see. So here if you observe, we are getting 2, 7, 9, 8, 3, -1, 3, 0, 1, all into some single dimensional thing. Okay. Now there is some other method that is all and the other method that is any. So what this all method will be doing? This all method will be returning if all the numpy array is having one or true values. Okay. So in that case only it will be returning us true. If any one of the value is 0 or false, then it will be returning us false. Okay. So here if you observe in this there is 1 0, that is why it is returning us false. Let's convert that to 1, then it will be returning as true. Okay. And similarly, any will work in the reverse manner. If any one of the value is true, then it will be returning as true. And if all are false, then only it will be returning as false. So if we consider this, there is one value which is true, we can say. So it will be returning as true. Let's make this to 0 and observe. Then it will be returning as false. Okay. And these are some functionalities of NumPy, and we'll be making some last video on NumPy in in the next video. So I hope you guys have understood everything in this video, and if you have any doubts you can comment it down. Thank you.